Charging and discharging of capacitor. Misconceptions. Number 1. Charging a capacitor fills it with charge. Number 2. The amount of charge on charging and discharging a capacitor is different. The aim of this experiment is to investigate the charging and discharging of capacitor. A capacitor is a device that is used for storing electrical energy in an electric field. It has two metallic plates. One is positively charged and other is negatively charged. They are close to each other but are isolated from each other by an insulator known as dielectric. Before carrying out the experiment, we should make sure that the voltmeter is in working condition. For that, connect the voltmeter and battery eliminator as shown in the video. Then switch on the battery eliminator and change the voltage of the battery eliminator. With that, see whether there is change in the voltage in voltmeter. Make a circuit connection as per the circuit diagram. Using the copper wires, connect the negative terminal of the voltmeter to the negative terminal of the capacitor and positive terminal of the voltmeter to the positive terminal of the capacitor. A capacitor has two leads. The longer one is positive terminal and the shorter one is negative terminal. Make a series connection between capacitor, resistor, battery eliminator such that we connect negative terminal of the voltmeter to one of the end of resistance box. Then from its other end, connect it to the common terminal form part of the two-way switch key. From the second line terminal L2, connect it to the positive terminal of the voltmeter. After that, from L2, connect it to the positive terminal of the battery eliminator. From negative terminal of the battery eliminator, connect it to the L1 of the two-way switch key. The graph shows that the capacitor's potential difference across its plates starts to increase as it charges up, and it takes 25 seconds for the capacitor's charge to reach 63.2% of its maximum achievable level, that is 3.8 volt of 6 volt from battery eliminator. Capacitor is being discharged, the potential difference across its plates starts to decrease, and it takes exactly 25 seconds for the capacitor to discharge completely. Connecting the battery to the capacitor, energy is stored in the capacitor. The capacitor is able to deliver this energy to power the bulb. Consider two metal plates of the capacitor. Due to the electric potential of battery, electrons get removed from metal plate A and it gets deposited to metal plate B. The number of electrons received by metal plate B will be same as the number of electrons lost by metal plate A. Thus, metal plate B becomes negatively charged conductor and metal plate A becomes positively charged conductor. In this regard, the net charge stored on the capacitor is always zero and in equilibrium with its surroundings. Therefore, the amount of charge on charging the capacitor is same when we discharge the capacitor.